In this reaction, we're going to see double displacement. In this video, we're going to see double displacement reactions that are neutralization reactions. So you'll be able to identify them and also predict the products of those reactions. And you've actually seen this before. We're just giving it a label now. So remember, when you do a neutralization reaction, you typically have an acid and a base reacting together. And when they do that, you get a pH that's closer to 7. So your acid will have a pH that's less than 7, base more than 7, and then at the end, you get something closer to being neutral. So for example, you get acid plus base gives you salt and water. That's generally what you see for a neutralization reaction. And so there's two main types of neutralization reaction. There's one where you have just a hydroxide base reacting with an acid, and that produces salt and water. You'll notice basically everything is aqueous except for the water, which is liquid. And the other type is when you have a carbonate type of base. And when you do that, a double displacement reaction happens, and you get Na2SO4, for example, so a salt, but also you get water and carbon dioxide. And this is generally the type where you have a breakdown that forms, where you have your double displacement happen first, then a compound that forms like H2CO3, and that breaks down into H2O and CO2. At first, this looks a bit difficult to spot that it's an acid-base reaction, but notice you have your acid over here, and then you have your base over here. Remember, bases typically do have hydroxides, but they can also be carbonate type bases, and that can lead to a neutralization reaction as well. This here is sodium bicarbonate, which is just baking soda, and it's reacting with sulfuric acid over here. And so you would carry this out in 2 steps, and we saw this in a previous video for double displacement reactions. In this video, we're going to focus on these type of acid-base reactions over here. What you'll notice is that there's not much of an indication that something's happening. If you have 2 aqueous solutions that are both clear and colorless, and at the end you get a solution of salt water, it's still clear and colorless. So there's not much to indicate that a reaction actually happened. So what do you think you could use to indicate that a reaction happened? That's right, indicators. And we'll take a look at that in more detail later on. So we're going to do a couple examples. We're going to write balanced equations between acids and bases and predict what our products are going to be. And then after we're done doing those examples together, you can do a predict, observe, explain video where you're going to watch the video and then answer the questions based on that video demonstration so you can see what it looks like in the lab. Here you're seeing hydrochloric acid reacting with NaHCO3, and you're trying to see what type of reaction has occurred. Let's go ahead and do some practice problems for neutralization reactions. So here we are. We'll do so we have NaOH and HCl. So this is one of those acid-base reactions where you have a hydroxide base. And so we're going to do our switch. Our H will switch spots with our Na. And so now we'll get NaCl because the Na went with the Cl, and that's going to be aqueous. How do I know that? Just to be sure, if we go up here, we have Na, and then Cl is down here, so they're soluble. So that's NaCl, aqueous. And then we have H with OH, which makes H2O. So this is our liquid here. So this is our base and acid reacting to produce a salt and water. Even though there's no precipitate or gas formed, this is still a reaction because we have a liquid form over here, which is H2O. So here we have another example. LiOH, our base, with our acid, bromic acid. So our Li will switch spots with the H. And so we'll get LiBr as our salt, which is a crisscross between Li and Br. And then our H went with our OH, so we get H2O, which is a liquid. You wouldn't put aqueous for H2O because aqueous indicates a watery solution. So you have something dissolved in water. This is just straight up water here. So H2O liquid. And I want to see if LiBr is soluble. It should be because, again, usually you get a salt and water, and typically that salt is soluble in water. Let's just take a look. So lithium's up here. Bromine's down here. Yeah, that's soluble as we predicted. So that's going to be aqueous here. And here we have our salt and our water. And after the neutralization reaction, remember that the pH is closer to 7. So pH is a little bit closer to 7 than before. So here we have our base plus our acid, and that produces salt plus water. And that's just a double displacement reaction that would be classified as neutralization. Remember that the type 2 of neutralization is the one where you produce a gas. It's typically when you have a carbonate base. So you can see here we have an acid and a base that is a carbonate-based base. And what you do is you get an ionic compound, and then you get water and carbon dioxide. And so what's going to happen here is the H is going to kick out the Na, and the Na will go where the H is. And so you'll do the crisscross between sodium and sulfate, and you get Na2SO4. And then you get the H combining with the HCO3, which makes H2CO3, and that's aqueous, as we learned before. Na2SO4, let's just double check if it's soluble or not. Na plus is up here. SO4 is down here. They're both agreeing with each other, so that's going to be soluble. So at first glance, you might think there's no reaction because it's just aqueous and aqueous. But then remember that this part here breaks down because it's one of those compounds that you saw up here that would break down to form H2O and carbon dioxide. So you can rewrite this equation at the end as Na2SO4AQ plus H2O liquid plus CO2 gas. And so this is still a neutralization reaction. We have our acid, we have our base, and then we have this is our salt, and then our water. And we also have carbon dioxide made as well, but that's okay. This is closer to being 7 than it was before. So let's try another example here. We're going to write a balanced equation for the reaction of calcium hydroxide and nitric acid. So you have to know how to write out the equations or formulas for these. So calcium hydroxide, crisscross it, is CaOH2. Nitric acid is HNO3. And as an acid, we have to put AQ. Let's double check what calcium hydroxide is. Is it dissolved or not, typically? So calcium hydroxide, insoluble there, but up here, right? So this is going to be a solid over here, and that's okay. So we have a solid here. It's insoluble. And let's see what happens at the end once we do our double displacement. So Ca will kick H out, and H will kick Ca out. So we'll get CaNO3 2 plus some HOH, which is just H2O. That's liquid there, and this is aqueous here. So this was our base. This was our acid. And this gave us our salt, the ionic compound made from the acid-base reaction, plus water. So we're closer to neutral at this point over here. That's a neutralization reaction. Let's go ahead and try this example out here. So write a reaction between hydrochloric acid and calcium carbonate. So here we have HCl, AQ, because that's our acid. I didn't balance the above reactions, by the way, so you can go ahead and practice that. Calcium carbonate, CaCO3. Let's see if it's soluble or insoluble. So calcium carbonate, Ca here is insoluble. Carbonate up here is insoluble. So that's a solid at room temperature. That's a solid. It didn't dissolve. It's not aqueous. That's okay. We can do our double displacement reaction nonetheless. And we get, let's see. So calcium goes where the Cl is, so CaCl2, plus the H goes with carbonate, so that becomes H2CO3. That we know is aqueous, as we've seen before. Let's see what calcium chloride is. Calcium is down here is insoluble, but chloride is up here is soluble. So chloride calls the shots because it's above there and wants to be soluble. So that's going to be AQ. And remember, normally we'd think, okay, well, now there's no reaction happening because, well, everything's AQ. But you spotted this compound over here, which is one of those ones that breaks down. So we can rewrite this as HCl, AQ, plus calcium carbonate, solid, arrow, CaCl2, AQ. And then, remember, this breaks down to form our water as a liquid and our carbon dioxide as a gas. And so that sums up and that's the last example for double displacement reactions and our neutralization reactions. In the first video, we focused on some types like that, where we had acid and bases reacting, and they produced two things that were aqueous, but then at the end, one of those things broke down to make water and carbon dioxide. So we just briefly saw the gas production type. And really, you're going to produce a gas when one of these compounds is produced at the end of the reaction. And that's why the reaction can happen. We saw double displacements that produce a precipitate. So you do a double displacement, both things are aqueous, and it's not even one of the compounds above. You might think there's no reaction. That's what would happen. You'd have no reaction because both things are aqueous and the ions are still just swimming around. So in cases like this where you don't have the above compounds produced, or you don't have a straight up neutralization where you have water and salt produced, if you have both aqueous, it's no reaction. But if you have something that's a solid, insoluble, a precipitate, then that's a reaction. And you'd have to check your solubility using your solubility charts. So from now on, if there's ever a compound that's produced in a solution, you can check if it's aqueous or not using the solubility guidelines in whichever reaction you're given. And then afterwards, to finish off in this video, we saw double displacement reactions that are neutralization specifically. We already saw the gas type, but we just reviewed it again. We recapped it right here, along with the example over here. And then we saw the type that where you have a reaction between a base that has hydroxide and an acid. And in that case, you get a salt produced and water. So you don't have two aqueous things. You have one aqueous thing typically, and then water as the liquid. I always double check just so you can get practice to see if the salt is actually aqueous, and you should generally see that it is. And again, this is called neutralization because when you mix the acid and the base, you get to a pH that's closer to 7 than you were before. So you can practice the questions in the worksheets and in these notes again. You can practice to predict, observe, explain, which will be very helpful to help consolidate the information. And there's also a few other videos embedded within this presentation that you can go over to practice these skills.